A beautiful thing about the periodic table is that it's designed to show the aufbau order. Since electrons largely determine all chemical behavior, their location is critical. Our best understanding of where the electrons are is known as the aufbau order, so the periodic table is tuned to it. Let's go ahead and work our way from hydrogen up to oganesson. This is a rather old form of the periodic table too. And while we do that, let's show where the electrons are. I believe we are right now at the stage of helium. We have a 1s2 orbital. Can you see that? 2 electrons are in it. Let's go to the second shell, 2s2. Let's go to more of the second shell, those 3 orthogonal p orbitals, 2p sub x, 2p sub y, 2p sub c. We are now out to neon. Third shell. And by the way, it's so easy to read this, right? 1s, 2s, see how there's all those letters. I even threw in these. Note that when you go to the D shell, you drop a shell. And for the F, we drop 2 shells. So just read this like a book. Notice also that that's 56 and that's 57. So make sure that you don't go from barium to lutetium. Okay, where are we? We are at 2p6. It's time for the third shell, 3s2. What comes next? Try to follow along. 3p6, 2, 4, 6. Third shell is complete. Third shell's not really complete, is it? Because we still have this third shell here. Don't forget about that. Fourth shell, 4s2. Now we go back to the third shell and fill up 5 orbitals. These are the 3D orbitals. Since there's 10 electrons, that's 5 pairs. They go by funky names. Let's not worry about it, but there are 5 of them. 1, 2. Notice how the radius is a little smaller. 3, 4, and 5. Weird, right? But we are within now the third shell. Go back to the fourth shell and the 4p, so that will be equal to this radius here. 2, 4, 6. Done with the third shell, and also did part of the fourth shell. It's time for now the fifth shell, then we'll go back down to the fourth. So I'm going to go a little faster here. I'm just going to read this like it works. 5s2, 4d10, 1, 2, 3, 4, 5, 5p6, 6s2, 5d, no, 6s2, you got to drop down 2 shells. 4f14, so we should see 7 that are 2 shells within. 1, 2, 3, 4, 5, 6, 7. Notice they increase in the number of lobes on them. Back up to 5d10. 1, 2, 3, 4, 5. So that's 10 electrons. 6p6. 1, 2, 3. There it is. 7s2. What's next? 5f14. Go in 2 shells, and there should be 7 orbitals. 1. Lots of lobes. 2, 3, 4, 5, 6, 7. Time to go up to, I think it is 6d10. 1, 2, 3, 4, 5. 7p6. 7p2, 4, and 6. And we are out to oganesson right there. Now, you might not be surprised that since this is such a predictable pattern, notice we're going within 1 shell, and we're going in within 2 shells. At some point, we should go within 3 shells. There's other ways of representing it, and I used to use them, but I kind of like the, oh, and by the way, I think we're going out beyond the known universe here. Boom, 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 boom. We're getting into G orbitals, things like that. And that's what I want you to be able to do. Generally, you'll be given something like this on a test, and you're simply asked to continue it. Ignore this. I think that's a page number. This kind of a system shows the infinite nature of the Aufbau order. Read it like a book. 1s2, 2s2, 2p6, 3s2, 3p6. But when you're following it, you have to go diagonally, right? So after 4s2, we go to 3d10. See that? That's a little weird. There's other ways of doing it, but hey, this works. Students usually get it. What would come after 7p6? Clearly, it's going to be 8s2. And then what? We have to go out here. We're, 3 elements from entering the G block. That'll be 5G. And you can work your way down. It's pretty logical. It's an infinite pattern. Beautiful thing. That is electrons and the periodic table.